Hello everyone, we will discuss problem sum of imbalanced number of false subarrays. So the problem statement says that if you are given an array, uh, they have defined an imbalanced number for it, which is that you have to sort the array, and suppose your array was initially 4, 2, uh, 1, 2, 4 and 8. So if you sort it, you will get something like 1, 2, 2, 4 and 4 and 8. And then you have to look at all the indexes from 0 to n minus 2, which is uh, in this case from 0 to 4. And then for each index, you just look at the adjacent element and you take the difference, and that difference should be greater than 1. So if the difference is greater than 1, then the index is called a good index, and the sum of like the total number of good index is the imbalance number. So for example, in this case, this index pair and this index pair is a good pair. So for index 2 and index 4, and the imbalance number for this is 2. Okay. Now the problem statement asks you that you are given some original array of some size n, and you have to look at all of its subarrays, and then for each subarray you have to find the imbalance number, and then you have to uh, take the sum. So total imbalance you have to find. All right. So how do we solve it? The brute force approach, or the very basic approach, would be to just, the constraints are like n is less than equal to 1000, so we uh, might try to go for an order n square solution, or n square log n or something like that. So the brute force approach, like the very basic one, would be just to look at all the subarrays. So like iterate over all the I and j's, and then for each subarray you will sort it, and then you will iterate over it, and you will find the uh, imbalance number. Okay, so this is fairly simple. You just after sorting it, you just for any index k and k plus 1, you take the difference, and that difference should be greater than 1. And then you take the sum, and that would be your answer. But the complexity for this would be order of n cube log n. Um, or you could even do it in order n cube if you are doing it smartly. But n cube log n, because n square is the number of subarrays, and then for each subarray you have to sort it, and then you have to then do an like a single iteration on it to find the number of find the imbalance number. So how do we do it a little bit more optimally? The way we will solve it is, they have defined a good pair as the indexes from 0 to n minus 1, such that array of I plus 1 minus array of I is greater than 1. Okay. Instead of finding these indexes, let's find the opposite. Let's find the bad indexes, which are the indexes such where array of I plus 1 minus array of I is less than equal to 1. So if we are looking at some subarray of size small n, then we will basically try to find the number of bad indexes, and then to find the good, like the imbalance number, what we will do is we will do n minus 1 minus the bad indexes, because indexes can be of only two types. Either they will follow this or this rule. So we are looking at the indexes which follow this rule, and then we are subtracting them from the total number of potential candidates, which are from 0 to n minus 2. So there are a total of like n minus 1 candidates. Okay. This will actually simplify our solution a lot. So let's look a little bit more deeply into this equation. Since we are looking at the indexes where this equality is true, we can divide it into two parts. So either array of I plus 1 minus array of I equals to 0, or it is equal to 1. Okay. Now, in our final solution, what we will actually do is we will um, fix. So instead of like looking at all the subarrays, randomly, what we will do is we will fix our subarray at some position L, and we will do this for all L from 0 to n minus 1. Like we have to look, what we will do is we will fix our subarray starting point at some L, and then we will gradually one by one we will increase the subarray size. So we will gradually increase our R, and we will keep a track of these pairs. Okay, so suppose we are at some L to R, and we at this point we know the number of like pairs which which fulfill this condition, which are a bad pair. So we can just do R minus L minus the bad pairs. So that would be the imbalance number for the subarray from some L to R. And then we will increase our R to some R plus 1, and we will update this information. We will update the number of pairs, and then we will find the new imbalance number for the new subarray. The advantage of this is that when we are going from R to R plus 1, we have retained this information. The information from L to R has already been like stored with us. We don't have to recalculate it. So that's why we are fixing our L and we are gradually increasing our R. Okay. Before moving on to the final solution, I also want to um, discuss these conditions again and gather some more insights from this. So the first part of this condition is simply the number of duplicate elements, because if two elements have a difference of 0, then they are the same elements. So the first part just boils down to counting the number of duplicate elements. The second part is a little bit more interesting. So what I'm saying is, if you have this sorted, suppose you have a sorted subarray, okay? Then if you look at this condition, and suppose this condition is what? Array of I plus 1 minus array of I equals to 1. We need to find these pairs. If I fix my array of I to some value, suppose I fix it to 3, okay? Then array of I plus 1 must be equal to 4, the value, not the index, the value. This pair of 3, 4 in any sorted subarray can occur only once. It cannot occur multiple times, and it is very obvious because suppose there is a 3 and then afterwards there is a 4, then a 3 4 pair cannot come to the right or to the left, because then the array will not remain sorted. So this array of I plus 1 and array of I, if I fix some value to array of I, then this pair of value plus 1 and value will occur at most once, or it will not occur. Okay. Now let's move on to the final solution. Basically, we need to maintain the count of these pairs, and let's see how we will do it. Suppose that we have already processed some subarray from L to R. That is, for this region, we know the number of duplicates, and we know the pairs where array of the sorted array of I plus 1 minus array of I is equal to 1. Like for this region, we know the number of bad pairs. Now suppose we are adding a new element here. Okay, we are increasing our R to some R plus 1. Now two things can happen. Suppose this element is a 5, okay? The value is 5. And in this region, 5 didn't occur at all. Like 5 was not present. And that is very easy to manage, right? We can maintain a frequency map, and we can just check if, in this L2R region, we have the frequency map updated for all the elements. So when we go to R plus 1, we will just check if 5 was present previously. So let's assume that 5 is a new element, the first case. That is, it is not a duplicate. Okay. In that case, this type of pair will not increase because this is only equal to the number of duplicates. Since 5 is occurring for the first time, this will not increase. But in the sorted array, suppose from this L to R plus 1 region, if I sort the array, 5 will come somewhere in between. What can, like, if there was a 4 present in this region, then that 4 would come before the 5. So what would happen is these types of pairs where the difference in adjacent element is equal to 1, that will increase by 1. So if if 4 was present, so we just check if the element with just one less value is present, then the bad pairs will increase by 1. Okay, I hope you understand why. So if a new element comes, it's not a duplicate, it is coming for the first time, then it can not increase the count of duplicates, but it can increase the count of the type 2 pairs where the difference of the adjacent elements is equal to 1. And it can do that in two cases. One is when a lower element is present. So if it's a 5 and a 4 was present here, just one less, then definitely the bad pair will increase. Suppose a 3 was present, a 4 was not present. Okay. And then there were some 2s, there were some 1s, there were some 0s, whatever. Then a 4 will not come here, a 3 would have come here, or a 2 would have come here. But whatever is the maximum element here, just less than 5. But since that is not equal to 4, then since the difference here is not 1, the bad pairs would not have increased. They are only going to increase if 4 was present. Now the second case is if an element just greater than 5 was present. So suppose a 6 was present here. Then in the sorted array, a 5, 6 pair will be present now, which was not present previously. Okay. So in that case also, so if a 6 was present, then the bad pairs will also increase by 1. Okay. So writing it a little bit more formally, if the next element, whatever it is not a duplicate, it is occurring for the first time, then you will check like the element just less than it and the element just greater than it, because this element can only increase the bad pairs in two ways. Either an element less than it must be present or an element more than it must be present. It will not impact the existing bad pairs. Suppose a 7 and 8 was present here. This 5 will not impact it. Suppose a 2 and 3, in this region a 2 and 3 was present, right? So let's say like this. Then that pair will not be impacted because these 2 and 3 is they're adjacent, and element 5 could only impact it if it was coming like between them. But it cannot because the difference is 1, right? So it will not impact the existing pairs. It can only increase the number of existing bad pairs. So you just check these two conditions. So if this is present, then your bad pairs will increase by 1. And if this is present, then also your bad pairs will increase by 1. All right. So this is the case for when the element is not a duplicate. Now the second case is if array of like the next element. So you're looking at L to R, you increase it, and this element is a duplicate. So suppose this was a 5 and a 5 was already present in the array. Okay. So in that case, the duplicate pairs will increase by 1. So in that case, if duplicate, then the bad pairs will increase by 1 because the number of duplicates is increasing by 1. But what about, these types of indexes, like where the difference is equal to 1? Will these types of indexes be impacted? Then the answer to that is no. Because, like I said, this 5 can only form two types of pairs, a 4 comma 5 or a 5 comma 6. Okay, and we have also discussed that, like way before, that these kinds of pairs can occur at most once in the sorted array. So suppose that a 4 was present here, okay, in the array. Let's look at the 4 comma 5 pair. The same thing will happen for the 5 comma 6 pair. If a 4 was present here, then when we came to this 5 for the first, like the first 5, uh, the first time a 5 was encountered, this, what do? We look at the element before it. So we we see if an element 4 was present. So since an element 4 was present in this region, the bad pair would increase by 1. So this 4 comma 5 has already been taken into account. When this 5 comes again, it will go somewhere here in the sorted array. So like this 4 comma 5 pair has already been accounted for, so we will not even check it. Now let's assume that this 4 came somewhere here. If it came here, then this 5 would have, made up. This 5 would have caught it. But if the 4 came somewhere here, then if the 4 came somewhere here for the first time, so when the 4 came here, each element checks to its left and to its right. So this 4 would have checked to its left, which is 3, and it would have checked to its right, which is 5. And this 5 is already like present in this region. So this 4 comma 5 pair would have already been counted for. Okay. So when a duplicate element is encountered, the number of these types of bad pair will not change. Only the duplicate count will change. Okay. So this type of pair will not change. Only the duplicate count will change. So the bad pair will increase by 1. So you don't need to check anything. You can just continue. Okay. Now, some doubts which might come to your mind is, what will happen in case of, do we do any sort of duplicate counting? Okay, that might come to your mind. And the answer to that is no. We are not, like, any pair duplicate counting in the sense I mean, like this 4 comma 5 pair, can it be counted twice ever? So the answer to that is no, because suppose you have fixed this L, right? You are going to the right. Suppose you encountered 4 first, okay? And at that point, a 5 was not encountered. So a 4 comma 5 pair was not counted. And then in the future, a 5 comes, okay? Then the 5 will look to its left. It will look if a 4 is present in this region. And since it is present, a 4 comma 5 bad pair will be counted. Now suppose a 4 comes again, then this time it's a duplicate, and we are not even like, uh, we will just increase the duplicate count. Uh, we will not increase the we will not even look at these types of pairs. And if a 5 comes later on, then the same thing will happen, like it's a duplicate. So these types of pairs, uh, like array of I and 1 plus array of I, these types of bad pairs are only counted once. So now I will show you the solution, the solution code. So what we are doing is we are fixing the L. So for I equals to 0, I is less than I plus equals to 1, we are fixing the L, and then one by one we are increasing the range. We are expanding the subarray to the right. Okay, so this is the R, which we are increasing one by one. So what we do is we maintain a frequency map. We increase the frequency. We check if it's a duplicate element. That means if the frequency count is greater than 1, then the number of bad pairs will increase by 1, and that's all that we have to do. Otherwise, the element is coming for the first time. We need to check if an element less than it was already present in the array, or an element greater than it was already present in the uh, L2 R minus 1 subarray. And then we will, in that case, we will increase the number of bad pairs. And in the end, we will since for some I to j subarray, we know the number of bad pairs, we can just the number of good pairs on the imbalance number will be the total number of candidates minus the number of bad pairs. And then we will return that. The complexity for this is, I think, order n square only. You can replace this map with an frequency array as well, because the number of elements are till 1000. That's all for this video. Thank you for watching. Bye bye.